Hello, my name is Moshe Kravchow, and over the next few minutes I will discuss the energy crisis, its relation to the global climate crisis, and what to do about it. This chart shows our historic energy consumption in the United States from 1750 to the present, from 0 to 100 quadrillion British thermal units. The lower section is our wood consumption, followed by our coal consumption, followed by our oil consumption, our natural gas consumption, our hydroelectric consumption, and our nuclear consumption. Our wood consumption starts to register on the scale around 1750 with the steam engine, when we started feeding our machines carbonaceous fuels. Around 1850 we started feeding our machines coal. Shortly after started using oil, followed by natural gas. We started using hydroelectric energy toward the end of the 1800s, and nuclear fuel in the mid-50s. This chart shows the trajectory of industrial buildup. Industrialization up to the Great Depression, the war buildup, followed by continued ascent to the first oil crisis, and then up to the present. Around 1950, our demand exceeded our supply capacity. We continued increasing our demand through imports. Around 1973, when we could no longer increase our supply and our supply started diminishing, we continued to increase our imports, and that's when the oil embargo hit, and our imports were drastically reduced, and we could no longer increase our production. We overcame that and continued to import more as our domestic production decreased. This is a crisis because it's a food crisis. We are dependent on natural gas to create fertilizers to grow food in the desert, and diesel to truck it from the desert to our plates. If we count all this carbon, all of this that's underneath the green line here, this is all carbon that we took out of the ground and put up into the air. This carbon got into the ground in the first place through our biosphere. The plants pull carbon out of the atmosphere, animals help process it through ingestion and excretion. We pulled it out of the ground and threw it up into the air above us. This here is a scale model of an equatorial cross-section of the Earth. The inner core, the outer core, the lower mantle, the upper mantle, the crust, and the atmosphere. There is the internal heat from inside the Earth that's radiating continuously in all directions at the inner portion of the crust, and then there is sunlight. The sun radiates on the Earth from the outside, but it only hits the Earth at less than half of the Earth's surface. That imbalance is what drives our currents, both our air and water currents. When the solar radiation strikes the surface, it can raise temperature by heating the crust, or if it strikes plant material, the plant will use that solar radiation to take carbon from the air, combine it with hydrogen, release oxygen and water. In effect, what that does is it lowers temperature. So it uses solar radiation to produce chemical reaction and cooling. When we release carbon that was brought into the ground by our biosphere and we put it back into the air, where it goes is it goes into that very thin layer between that brown line, which is the surface of the crust, and that first pencil line, which is the tropopause. When we talk about global warming, we're talking primarily about the warming in that very small layer. This diagram here is also an illustration of how much carbon we, as the United States, took from the ground and put up into the air. So, to undo this, we need to bring this carbon back into the ground. When the surface of the crust is covered by a carbonaceous layer, it holds moisture. And when the plants are growing without a sustained animal interaction, they grow like this. So that the plants grow, and then they get crowded, and they die, and there are not animals that bring that material to deposit it on top of the crust. So it stands and it creates a sponge, which is a mixture of fire fuel and air, which creates the conditions for fire. Once a fire comes through, it dries out the land even more, so when it rains, the rain washes away, causes floods, and when the new plant material does grow, without animal interaction taking down the old dead stuff, it grows up around it, again creating the conditions for fire, and the successive waves of fire create desert. This is what we can do about it. Since we lost our wildlife population that did the work for us, we need to go through with metal blades and get it started. So in the areas that are like this and are overgrown, we need to take our metal teeth and cut it up so that it creates the layer on the ground that can now retain water. Here is the same site about 1.5 years after the treatment. The carbonaceous layer on the ground is water retentive, and new vegetation is growing up, which could be nutritious for wildlife, which could digest it and bring it down to the ground, creating more topsoil and building up the soil. Next is a demonstration of technology to work with our vegetation, that this will cause it to become more water retentive, reducing its fire hazard and setting the conditions for more vigorous growth. More growth will pull more carbon out of the atmosphere and produce more cooling. In summary, our historic biosphere pulled carbon out of the air, stored it in the ground, and produced cooling. While we started burning carbonaceous fuels, we took that carbon out of the ground, put it back into the atmosphere, and produced heat. So by working with our biosphere, we can reel in all this carbon that we put up into the atmosphere, and at the same time provide distributed food supply for us, so that we lose our dependency on this oil natural gas.